Hey, what's up, chemists? This topic from Alex asks us to design a galvanic cell from two half reactions, which it specifies for us. In this example, we have a half reaction involving zinc, and we have another half reaction involving nitrogen. There's one thing that I want you to recall before trying this type of topic, and one thing that we need to specify. The first thing is that since we have a galvanic cell, we want to make sure that our E0 for the cell is positive, that it's going to be greater than 0. The second thing that I want to point out is that E0 for the cell is always going to be equal to E0 for whatever our reduction half reaction is, minus E0 for the oxidation half reaction. So once we identify which reaction will be a reduction and which reaction will be an oxidation, then we'll need to combine them in that way. And if we do it right, that will ensure that our E0 value is greater than 0. So let's go ahead and get started. So the first question asks us to write a balanced equation for the half reaction that happens at the cathode. So our reduction happens at the cathode, and our oxidation is going to happen at the anode. And to ensure that we have an E0 for the cell that is greater than 0, we want to make our cathode more positive and the anode less positive or more negative. Okay, so when we think about what half reaction happens at the cathode, it's going to be the most positive half reaction. So in this case, the most positive one is actually this one for zinc. Even though it's a negative 0.763, that is more positive than negative 1.16. So our half reaction at the, got a hair on that sheet. The half reaction at the cathode is going to be zinc 2 plus 2 electrons going to zinc solid. The next question asks about what happens at the anode. So the anode is going to be most negative or the least positive half reaction. And you should know that for this one we need to turn it around and write it as an oxidation. So we'll have N2H4 aqueous plus 4OH minus aqueous going to N2 gas plus 4H2O liquid plus 4 electrons. All right. Write a balanced equation for the overall reaction, and we need to be sure that the reaction is spontaneous as it's written. So for this, we want to, well, first of all, make sure that we have a balanced number of electrons. And we want to make sure that the half reaction that we think is running at the cathode, make sure that that is going in the forward direction, and that the one that we think of as being an oxidation, that it is actually included in our equation as an oxidation. All right, so in our examples here, we have 2 electrons in one half reaction and 4 electrons in the other. So we are going to have to multiply this half reaction by 2 before recombining. So when we do that, we're going to get 2 zinc 2 plus N2H4 plus 4OH minus all of that going to 2 zinc solids plus N2 plus 4H2O. And of course, when you enter those into ALEX, you need to include their phases correctly, or ALEX will yell at you. Next question. Do we have enough information to calculate the cell voltage under standard conditions? Sure we do. We have E0 values, so we can calculate those. And if we said yes to the previous example, it wants us to do it. So we need to remember that E0 for the cell is E0 for the most positive reaction minus E0 for the least positive reaction. So it's going to be E0 for the zinc minus E0 for N2. So E0 for our cell is negative 0.763 minus negative 1.16. And I managed to start this tutorial without actually calculating that out. So let's do that now. 0.763 negative minus 1.16 negative gives us 0.397. So E0 for the cell is 0.397 volts. And it wants us to answer to two significant figures, so we would round that to 0.40. That would be it. Okay, so the key to this kind of problem is to remember that we want to construct a cell. We want to match up our half reactions such that the E0 for the cell is positive, and we always want to have E0 for the reaction that we think is going to run as a reduction, the E0 for that minus the E0 for the reaction that will run as an oxidation. The reduction part happens at the cathode, the anode part happens at the anode. And that is it.